Right, so yeah, good morning. My name is Guerrero. I'm a master's student at New Mexico State University. And I'll continue a little of the talk that Ramesh just did right now. We worked together on this project. But I'll focus a little bit more on two aspects of the architecture, which are the RESTful microservices and document databases. And also, I will explain a little bit about the technologies that we actually use to implement these two concepts in our architecture. So here is kind of the same architecture that he showed, but well, in a different organization, but it's the same thing. And what I'm gonna focus will be on these two boxes down here that is called instance 3 and instance 2. There's actually where there are the microservices, and I'm going to explain a little bit more what both of those are and the document database. So first, he actually did a little overview about what is a microservice, but I'm going to explain it a little bit more, and also that's important for the next part. So I like this picture. So on the right side, you can see there is what is called traditional application. It could be a monolithic application or three-tier approach. So the idea of microservices is that you break up all the system in small pieces that are easier to configure, easier to develop, can be developed by different people, and can be implemented in different servers, different locations. So if you see those, so the traditional approach would be all these applications that we install in our computer. For example, you go there, there's like a big application, you hit next, finish. That's a whole thing that have been developed until the guy or the guys that were developing that don't finish, you can't use it, right? And on the other hand, and you could break like in 3 tiers, but it's a bunch of code, takes like a lot of time to run. And on the left side, so these green and red boxes and the other boxes are examples of microservices. So, and they all communicate over the internet, over HTTP. So instead of being all together like in one single application. And one of the advantages are the guy that is programming the green box over there there could be a guy programming the green box and another guy programming the red box, and that could be different programming language, could be one Java, could be the other C. Doesn't matter, like the guy that's doing one doesn't need to really wait for the other guy to finish. He can finish and deploy in different servers a whole different architecture. And they all communicate through the network. So as long as it has been developed correctly to communicate over the network, doesn't matter where it is or what kind of language have been used to design that. And it connects a lot with the second concept that is the RESTful API. So the RESTful API RESTful is a concept of having applications communicating over the network using HTTP or HTTPS protocols. So again, if you could imagine that these boxes over here with like programming languages inside could be different microservices, or they could also be different devices accessing some resource over the internet. So you can see it doesn't matter the language that has been used or the operating system that device uses, as long as it can access the internet, which pretty much everything now can, it can make use of the microservices and get the same results. So this is our design for the microservices. So as I explained before, our idea is we have a bunch of tasks that need to be executed. And instead of having it executing and running in a local computer and having the user to download all the data and install a lot of programs in their laptop or something, we could have it's kind of a website, like in a simpler way. But that website is actually backed up by different microservices that can do different tasks. So the microservices are really a small task, but that is important to the whole system. And you combine these microservices as you like and as you need over the internet and just get the results. So you don't need to transfer data, download data, or upload data somewhere. You don't need to really not even know a lot of programming. And so the idea here, you can see, let me go back. You can see up there it shows www.capstone.org API v1. That's just like a website, right? And down here after the cloud, you see /slicer/run or /something/run. All these slashes, those are actually the RESTful API. So you have your basic website, and that's exactly how our project is working. So you have a basic website, and after the slash comes whatever name you want. Of course, you should develop those names in an easy way to understand and to remember. But whatever name you want, and when you go open your browser, type that, type with this whole URL, you access the microservice. And so the microservice is responding. Different microservices are responding on different URLs. And also, inside the box, as you see, there is, so there are names like slicer, threshold, readnet CDF. Those are just the tasks that each box does. It doesn't matter what it is. It could be, sometimes I like to make examples, like if it was a calculator, instead of having a whole application that is a calculator, one box could be addition, the other could be multiplication, the other is division. And they don't really care about if each other is working, if the other is running. Doesn't matter. They just do their own thing. And they respond in different, they can respond in different ways. For example, it says JSON or HTML response. And that is, HTML is just, you could show in your screen the result, or if you are programming something else, you have some other application, could respond in JSON format. That's just sending the data to your application. And so those two, the microservices and the RESTful API, those are concepts. And how did we implement that? With Flask. Flask is the framework that allows us to implement both of those things. And why did you use Flask? First, Flask is super easy to do. It's lightweight. It's in Python, which is nice. It's an easier programming language also. And it's like pretty easy, pretty fast to prototype, and it doesn't take too long to deploy. And I wanted to show, so this box over here, this code over there is actually an application. It's actually a website in Flask. That if you just type a few lines over there, you actually will have a website that say "Hello World," and it seems like simple, but right there you can see actually both of the concepts of microservices and RESTful API. When you see over there add app.route and there's a slash, remember the slash from the slides before, that's exactly the route or the RESTful API that it's going to respond. And when you access that website, in that case it's just showing a slash, but could be whatever name you want. When you access that, what happens? It shows "Hello World" in our screen. So just that, if you actually compile that, it works. And so you can imagine, you can just type whatever, where it says "return hello world," type something else that you want your program do, and it would work. And I'm going to jump a little bit now to the document database. And first, I kind of wanted to explain what is a document database. And it's different from the concept that I think everybody has about database. There are tables and rows in a table. And document database is not like that. It's kind of a new concept. It's been there for a while, but it's still new. The difference is that, so first, we see over there user collection. So collection is like a table, for those that know the traditional database. And instead of rows in a table, you have a collection, and inside the collection, you have documents. But the difference is if we see document 1 and document 2, we are storing data about some people. The first document has a name, has a country, has an age, and last use. The second one doesn't have last use. And if you go to the third one, it actually has a name, doesn't have country, and has first use instead of last use. They are not really, it has a picture that all the others doesn't have. So it's kind of, you can see that they are somewhat different, and they could actually be pretty different. And the idea is actually document database. It's a document, you can make sure that a document is all the same. And that's the idea. The document database doesn't care if all your data is not structured the same way. And if you could put that in a database, in a regular database, but if you imagine that you have a bunch of different fields that one document have and the other doesn't have, then your database would be, most of the database, a lot of blank space because you didn't use that. And that's not nice, and that's not optimized. And as you can see, when you make a query to this database, it actually responds in a JSON format and brings you the whole document. So the whole information about that first user or the second user. And so these are some advantages of the document database. And by the way, I have over there MongoDB, that's the database that we use it. It's a kind of document database. It's schema-free, so like I said before, you don't really have to enforce a schema. All the documents or everything that is going to go into this database has to be exactly like this: user, age, country. You can make it heterogeneous. And that makes it easy to deploy and modify. If I don't want it anymore with name and age, I want something else, I just modify it like really easy. I don't even actually have to care. It makes it great for rapid prototyping. So one thing about schema-free, if you had a database, a regular database, and you need to add another column now to the database, for example, it may take it may take weeks to actually just insert that column in the database because you have to go row by row and adding that. And right here now, you just insert the new document with more information. And it's also easy to scale. So even MongoDB has some features that allow you to break into collections the database, and you just put those in different servers. It's just like that, just work. And this is how we store our documents. So if you remember from the last talk, Ramesh was talking about workflows and tasks, and I was talking also about microservices. So first we have a user, and the user can have his credentials, and the user goes into the system and create a workflow. Workflow is a bunch of tasks that he want to execute. So get this data, then slice for this city, then get me the temperature, then convert it to something else. All these different tasks go in a workflow in an order. So he creates a workflow. And that workflow has different tasks inside. I just had one right there called the slicer, but it could be more. I just didn't put more because it doesn't have space. So you see that users will, of course, create different workflows. They want to do different things. And they could have in the workflow 10 tasks or 2 tasks or just a few. And that makes it really good to use document database. Makes it easier for us to store that. And also it shows, because we can store a bunch of different kinds of information, text, dates, and pictures, and whatever. You could do that in a regular database too. But it makes it easier for us to track the whole workflow and redo it and reproduce it. And both the two technologies that we used, just going back a little bit again, Flask and MongoDB. And the idea of this slide is just not that we just selected these two technologies just because we wanted. It's being used for a bunch of big companies, and that's actually funny or interesting. For example, Pinterest use Flask for the whole website, and they have 12 billion requests a day in there. And Flask can handle all that. There's also, I didn't put the picture up here, but Netflix used it to be monolithic, the approach that we saw before. And they moved, I think, 6 years ago to microservices. So when you access their website, everything that you see, it's not that it's just, it's browsing different websites and putting it all together in your screen. And they have about 500 microservices just to show all that stuff. So recommended might be one thing, recommended movies might be one coming from one location, and the pictures might actually be coming from another location and putting it all together in the website. And so conclusions of future work. First, it just worked for us in less than 3 months. We were able to design an initial architecture. So and just by seeing that other people have been working, other companies have been working, we see that it's a pretty good approach, and we should continue with that. But we still have to implement some other things. The first is to implement automated deployment for microservices. That is, so I said before that we have different boxes for microservices, and one box can be used more than the other. The users could be accessing more that box. So we could actually have an automated deployment if we see that this service is being used too much by too many users. It just automatically deploy another instance as another, so it's always available. That could be done. And also implement more microservices. So the more microservices here is more tasks. So like I said, if you had a calculator today, we just have the four basic operations. We need to implement more operations because the users might not need just multiplication, addition, and all that. And actually have a UI. We have a basic UI, but that's not the way that we want it. And that goes exactly like Ramesh said before. We wanted to have a UI to allow the user to easily use this without not even knowing any programming language, because that's kind of the idea. If there is a city manager that just, like he said in Austin, he just want to see some data about his city because he needs to do planning. Probably he doesn't know programming language. He doesn't have time to be learning that. So he can just go drag and drop and actually be processing all this data. And also user login and authentication. That's for 2 reasons. First, to avoid abuse of the system, and also to allow the user to save their data and to reproduce and get the data again. And also using the DB to discover, share, and rerun workflows goes along with the login. So if you are a user there, you can make your simulations, and then you go back next day to see it again or share with someone. And finally, actually deploy it for the users because it's not available yet for people to use out there. It's just here inside your car. I think that's it what I have. If you have questions.
Yeah, let's